Hello, this video is to calculate what r squared, the coefficient of determination, is and how it was calculated. In another video in the Chapter 7 notes, I show you how to calculate r using a different method. It's more focused on r, but we all know that r and r squared are the same thing, just r squared. So you could get to this value in the other way or this way. This way focuses on the residuals and the standard error of the residuals. It goes along with this worksheet that you can see in front of you here. It has the height of people, I believe, and then also their weight. So trying to kind of make an association there between height and weight. But on the TI Inspire, I run through how to calculate r squared. Now the calculator will automatically do it for us, but we want to see how it works, manually, like what's behind the scenes and why this works and what it really is. So we can see our r squared here is 0.566. I just let the calculator do it for us. And then I'm going to calculate it the long way. And you can see I got 0.566 as well for my final answer. But let's get into it and see what this is all about. So the list is height and weight are here, my two lists. I did a one variable stat on both of those lists so I could get my different statistics. I'm going to need this statistic right here, this 21. This is the standard deviation in the y direction only for weight, in the y direction only. So this is a graph showing weight and showing all the variation of just the weights only, just weights. So you can imagine what the standard deviation of this set would be. The center's right about here somewhere, like at 150, and you go up just a little bit, like halfway up and halfway down. It looks like it's going to be about 20-ish. So when I go back here and I see this is 21, that makes sense to me. With a mean about 150, like I said, it's 153, and a standard deviation of about 21, which I thought was about 20, just looking at this variation of just the weights. So what we're trying to do is explain when I put an X value on that and I make a regression and I try to make an association here, how much of this original variability, which is determined, like you can see that with the standard deviation of 21, so how much of that 21 can be reduced by adding in an X variable and then comparing those, right? Saying, well, I'm going to associate those up. So now instead of all the variation in the Y direction, now I have residuals from the regression line that become my new error. So this is the predicted value on the line, right? That's your predicted value. Let me move this out of the way. And then the actual value are the dots, of course. So the difference of those is your residual, right? That's when we have residual graphs, and that's basically your error, right? There's a little error here, there's a lot more error here, there's a little teeny error on that one. So we have different types of error for each actual data value from the predicted and the actual, right? This is the actual, that was the predicted. So there's error involved there and there's variation. But the whole idea is there's less variation now. These distances from the center are all going to be actually smaller than if I would have taken this distance to the center, like 190 to 150 and 200 to 150, right? 200 to 150, that's 50. But now, here's my 200 point. I don't have to go to 150 anymore down here in the center. I only have to go to the regression line. So that's a lot shorter of a distance, right? And that's true for all these, well, not every single point, but in total, overall, the variation will be smaller now. So you've reduced the variation from just total variation to, hey, what if I associate it to the height of the person? Now I have less error going on. So what you're going to see in the spreadsheet is the residuals. I'm going to square those residuals, right, and get an average or get an area. So let's take a look here. So these are all the residuals. I took the the weight of the person, just the y axis, the y variable, and subtracted what the prediction would be for my line, my regression line. So this gives you a y value on the prediction. The list is the actual. You subtract those to get all your residuals. So these are all my residuals, right? I didn't square them. You didn't. In this method, you don't need to square them. I take that back. So these are all my residuals, and I'm just kind of looking for an average residual, right? What's the average residual? Well, the mean will be 0. If you added up all the different residuals, you're going to get 0. Some are positive, some are negative. You're going to get a 0 on there. So this is really close to 0. The important piece is the standard deviation of the residuals now. So I can see this already, that I used to have a standard deviation in the y direction of 21, but because I've associated it with the height, now I have a standard deviation in the errors of 13.8, which is less than 21. So I've reduced the variation. So they just want to know, like, what percentage. That's what r squared is, the coefficient of determination. It just says, well, how much did I reduce that error by? What percentage did I reduce it by? So that's what I do up here. You can see we're just doing a percentage. So we do square it. That's just part of the formula. So because you don't want negatives and things like this, you just want a percentage. So we take the J5 squared, this standard error in the residuals. This is what we ended up with after we made an association on top. And then on the bottom, this is the standard deviation that we had before. So that's the 21 on the bottom. So we got the 13.8 on top squared, and then the 21 squared on the bottom. So this gives you a percentage. Granted, it's kind of an area percentage. You're getting an average residual. You're squaring it to get an area. So this is like a percentage of areas. So this is how much variation you have left over. So we still have 43% left over from what we started with. So then if the question is, well, how much did you reduce it by? I reduced it by 1 minus that number, right? So if 43% is left over, that means 57% was reduced. So that becomes 1 minus that number. So 56% was reduced, or 57% was reduced by associating it with height. That is your r squared. That's what r squared means, the coefficient of determination. 57%. Let me go back to the graph. 57% of my original variation was reduced, and I only have 43% left over in this association. That 43% is not being accounted for by the height. It's going to be accounted for by other variables, which you could add in and stuff. So we have other variables going on, of course, right? It's not just the height of the person that determines their weight. But a good portion of that, right, 57% of it is because of that, or not because of it, but can be associated because of it, right? The other 43% is other stuff. So that's coefficient of determination.